any association that exists among a set of variables we can refer to as a correlation between all of those various variables. Now for us, we're really just going to restrict ourselves to looking at correlations just among two variables and just kind of keep it there. And so one common way that we might be able to look at and understand relationships between two variables, of course, is by using a graph that has two dimensions. And of course, when both of the variables are quantitative, we can use a scatter plot to be able to represent that. I do also want to make sure that you understand that this term bivariate data is a very common term that you should be familiar with, and it really just literally translates into two, since bi is two, variate is referring to variable, and then data. So two variable data, where of course the first variable would probably correspond to x, and the second variable would correspond to y. So we may see some patterns develop possibly when we're taking a look at bivariate data and looking at scatter plots. And so these four right here are not the only types of patterns that, of course, that you might see, but these are some of the more common things that we may be able to encounter and classify. So if ever you have scatter plots that follow the tendencies of those first couple of graphs, you can see that they follow a pretty linear sort of association. And so in both of them, we can say that they are both linear associations because the data follows pretty close to a line sort of path. However, in the first case, you can see that as x is increasing, y is decreasing. So we can say that this is a negative linear association whenever the slope tends to kind of be negative like it is there. And then, of course, this would be a positive linear type of association. In the third one right there, it's clearly not a line whatsoever. And so anytime we have maybe some sort of a pattern developing among the data, but it's not a line, then of course we could classify it as nonlinear. And if it did develop the pattern of a shape that we could name, we could probably name it a little bit more specifically than just nonlinear. I guess we could say that right there is also nonlinear because it's not really following a line path. But in that particular case right there, like it's just very scattered and random and really not following any sort of a pattern. So whenever we have something like that, we typically say that there is very little or no correlation. So somewhere in that spectrum of little to no correlation existing between the variable x and the variable y there. Some other things that may happen when we're looking at data that we just kind of want to note. So on the right-hand side over there, sometimes we get some values that are just far removed from most of the rest of the data. So whenever we have that occur, usually refer to that as an outlier. And usually we do have concrete ways to determine if something's an outlier or not, rather than just kind of looking at the picture. But I think clearly in that situation, we can definitely say that's an outlier there. And then sometimes also in data, you might have your data here, but if you kind of group it by a certain sort of like categories or something like that within the data, you might start to see kind of little cluster patterns happening there. And so sometimes we'll see clustering happen within data when we break things up into subcategories. So those are some other things that we kind of want to look for as we are examining scatter plots. So to kind of reinforce some of the correlation aspect stuff that we just saw here, we're asked to determine whether there is likely a positive or a negative association between the variables in each situation. So by positive and negative, we're really kind of assuming probably like a linear positive or negative association. And when we think about this, we really want to think about the fact that if there is a positive correlation, really what that means is that as x is increasing, then y is also increasing, so they both go the same direction. And then also if x was decreasing, then y would be decreasing. Whereas if we have a negative correlation, then in a negative correlation like that, as x is increasing, y is actually decreasing. So there's kind of that opposite direction. And then similarly, if x was decreasing, we would expect y to be increasing in a negative correlation. So let's take a look at these examples. So in the first one right here, we want to establish what type of a relationship we might see between the magnitude of an earthquake and the cost of its damages, right? So really kind of what you want to think about there is maybe if you think about the magnitude of the earthquake and think about, okay, what would happen if we increase the magnitude of an earthquake? How would that possibly maybe impact the other variable here, which is the cost of its damages, right? So the magnitude of an earthquake is its strength, right? So the stronger the magnitude, the bigger the earthquake, which means, of course, it's going to cost more in damages. So that means, of course, the costs of damages are also going to go up. So if both those variables are going to increase together with each other and then also, of course, decrease with each other, then we would specify that as being a positive correlation, positive linear correlation between those two particular variables because of that aspect. In the second example, between altitude and temperature. So if we think about altitude, altitude is really your elevation, right? So like if you're climbing a mountain, you're getting higher and higher and higher. So if we assume that maybe you are increasing in altitude, what's going to happen to this other variable of temperature? Well, the higher you go up on a mountain, the colder it's going to get, right? So the temperature is going to decrease the more you gain in altitude. So right there, because those variables are going in different directions, then we were going to be experiencing what could be modeled with a negative correlation in that particular example. And then last of all there, the height of an adult and the cost of a cell phone bill. So if we think about an adult's height and we increase the height, what's going to happen to the cell phone bill cost? Well, I don't think there's really a definitive way for us to say that it's going to increase or decrease, right? Because it's probably going to be like scattered all over the place, because I don't think adult height really has too much to do with cell phone bill cost, right? So in something like that, we would probably expect there not to really be a correlation in there. So we might just say that there's probably little or no correlation that exists among those two particular variables.